Alright, today's notes are over section 3-2, angles formed by parallel lines and transversals. We're going to prove and use theorems about angles formed by parallel lines and a transversal. So the first postulate we're going to talk about but not prove is the corresponding angles postulate. If two parallel lines are cut by a transversal, then the corresponding angles are congruent. So like in this picture, angle 1 and angle 3 would be congruent. So let's look at the alternate interior angles theorem. It says if two parallel lines are cut by the transversal, then the two alternate interior angles are congruent. So angle 1 and angle 2 would be congruent. So that's what we're going to prove next. So we're going to prove the alternate angles theorem. So the first step, it says given that L is parallel to M. So that is our given. If I could spell given. And that's what we're given. L and M are parallel. So next, we can say angle 1 and angle 3 are corresponding angles and they're congruent, right? Because up here it says in the corresponding angles postulate that if I have corresponding angles, then they're congruent. So angle 1 is congruent to angle 3, and that's by the corresponding angle postulate. So then if I know that angle 1 and 3 are congruent, we can talk about angle 3 and angle 2. What type of angles are angle 3 and angle 2? Well, angle 3 and angle 2 are vertical angles. And by the vertical angle theorem, I can say that those two things are congruent. That's the vertical angle theorem. So now that I have angle 1 congruent to angle 3 and angle 3 congruent to angle 2, I can say that angle 1 is congruent to angle 2 because of the transitive POC. Alright, let's look at the next one, the alternate exterior angle theorem. It says if two parallel lines are cut by a transversal, then the two pairs of alternate exterior angles are congruent. So two parallel lines, in this case x and z, which is what I'm given, and I want to prove that angle 4 and angle 5 are congruent. So let's start off with what we're given. X is parallel to z. So since I know that these two things are parallel, I can talk about angle 4 and 6, right? I know that angle 4 and angle 6 are congruent because of that vertical angle postulate because of that corresponding angle postulate that we talked about above. So angle 4 is congruent to angle 6. So now let's talk about angle 6 and angle 5. What kind of angles are 6 and 5? Well, they're vertical angles. So since they're vertical angles, I can say that angle 6 is congruent to angle 5 by the vertical angle theorem. So now I have angle 4 is congruent to angle 6 is congruent to angle 5. So just like above, we can use the transitive POC to say that angle 4 is congruent to angle 5, which is what I want. And that's by the transitive POC. Alright, let's look over at the back side. Alright, so same side interior angle theorem. It says if two parallel lines are cut by a transversal, then the two pairs of same side interior angles are supplementary. So I'm given R and S are parallel. We're going to prove this theorem's true. So the first thing I need to do is say that R is parallel to S because that is my given. So we can use any theorem that we've used before or proven before. So let's start off with angle 7 and angle 9. What type of angles are 7 and 9? Well, angle 7 and angle 9 are corresponding angles. So we can say that they're congruent by the corresponding angle theorem. So if I'm going to talk about supplementary, I know I'm going to have something with equals and measures. So in order to have something with equals and measures, I can't have congruent anymore. So to get this to not be congruent and to just be equal, we use the definition of congruence to say that they're equal. So now that I know that measure 7 and measure 9 are equal, then I can talk about maybe measures 8 and 9. What do I know about 8 and 9? Well, measures 8 and 9 are a linear pair, and part of the definition of linear pair says that they add up to be 180 degrees. And that's the definition of a linear pair. Well, I know I eventually want 7 and 8 to be supplementary, which means their measures have to add up to be 180, which I feel like I might be close, because I have 8 and 9 add up to 180, but is there any way I can switch out that 9 for a 7? Well, I can, because I said up here that measure 7 was equal to measure of angle 9. So now I can say the measure of angle 8 plus the measure of angle 7 is equal to 180, because I use the substitution POE. I substituted in measure of angle 7 for the measure of angle 9, because I said they were equal up here. So then the last thing I would need to say is angle 7 and angle 8 are supplementary. And I know that's true because the definition of supplementary angle tells us if they add up to be 180, then they're supplementary. Alright, so we're going to kind of organize this new information that we got. So if I have angles like this, I know that these are corresponding angles. I know that those angles are congruent, which means if I have an equations, I'm going to set them equal to each other. So 3x minus 4 equals 2x plus 46. So when I solve, I get that x would equal 50 in this example. The next set of angles I have are alternate interior angles. I know that alternate interior angles are congruent, and if they're congruent, that means when I'm solving for them, I set those two equations equal to each other. So 5x plus 10 equals 7x minus 30. So when I solve, I get that x equals 20. The next set of angles I have are alternate exterior angles. And I know that alternate exterior angles are congruent, which means if I'm looking at equations, I can set those two things equal to each other, or even just angles. So that means these equations need to be set equal to each other. So when I solve, I end up getting that x in this example equals 22.5. And the last pair of angles, these are same side interior angles. And I know that same side interior angles are supplementary, and supplementary means they add to equal 180 degrees. So in this case, I would take 4x plus 3x plus 5 and set it equal to 180 degrees. And so when I solve, I end up with x equaling 25.